And I want to tell about our first speaker for today. This is Mykyta, and his talk named Serverless 2049. Oh, a huge work was done to prepare this talk because guys was needed to test different application written in different Java-based environments. We can find answer. Is Java not so performable as it was? And should we choose another one language, for example, for clouds, or Java still great? So let's invite here Mykyta and Tatiana. Or you already there. Hi, Mykyta.
Yeah, hi.
So, couple words, please, about your speech.
Yeah, thank you for this introduction, Igor. Actually, yeah, topic is really holy war. When we are talking about serverless and Java, people may share completely different opinion about this topic, and I hope I will bring some piece of light to this discussion, or maybe make it even worse, and holy war will be even more bigger. So let's take a look.
And yep, my goal as a moderator today will be to sound your questions, guys. So please feel free to post your questions in any of channels which is comfortable for you. So it might be YouTube, Discord, or we are community platform, and we will be glad to sound your question and to answer them.
Yeah, colleagues. And you can, of course, not only questions type, your experience, for example. So, what do you think about Java is good for clouds or not? For serverless. You can write right now if you have such experience. Okay, let's go.
Oh. So let me bring the slides on the table. Please say when you can see them. So they should appear.
Yep, we see it.
Yeah, awesome. So as Ihor said, we will be talking about serverless today. Actually, the speech called the Serverless 2049. Actually, for me, it's very excited to be here today with you guys. This is my first big conference. I have attended some small talks, but never have talked at the such high level. Actually, with such level of preparation, when you are joining, there is an operator behind the scenes. You don't know about this, so I had talk you some secret to you. Yeah, and actually the level of organization is great. Thank you to the organizers. Thank you to Igor, Tatiana, and everyone who participated in the preparation of this talk. Before we start, I'm located in the Kiev, in the Ukraine, and right now the situation here is pretty, yeah, as you know, pretty hard. So organizers share with me the information about the foundation which they support. So if you are able and want to join and contribute some, we will appreciate a lot your donation and help to the Ukrainian medics. So this Leleka Foundation helping the injured and wounded people. So if you want to make something good and help us, we will appreciate this a lot. Yeah, so let's go further to the topic. As I said, Serverless 2049. Let me present myself. My name is Mykyta Berehulia. I am from the Kiev, as I said, working in VPAM at position of senior software engineer. I am not yet McKinsey consultant, and yeah, I had done this research, this speech not alone. Some people had helped me, actually a lot of people. We have a community in the Kiev, Java lineup community. We are inspired by the Java and like to work with Java technologies. And that what I will show you had been done together. And you can see all the people who had participated actually directly in the writing code or some any other kind of technical contribution. So thank you also to all these guys. But let's get back to the topic. Actually, some people had asked me why the topic called Serverless 2049. Is it something related to the Blade Runner and this movie? Actually, I will tell you in the end a funny story about this name. And actually, when we are talking about serverless, we see a future very dark. You may ask why, and I will answer you that we have received a message from the future. Yeah, actually, some kind of cloud time machine had bring us the message from the 2049, and I propose you to hear it right now.
Serverless 2049. Cloud providers are more dominant than ever. The last on-premise systems are down. The resistance, known as serverless, is fighting for the remaining money, trying to find the best approaches to utilize available resources.
So, as you understand, the people in the future, they're in pretty bad situation. So the cloud providers has conquered the world. And if you want to develop something and host it in some your on-premise service in your mom's bedroom, it's not available anymore. You should push everything to the cloud. And people are fighting for their money and trying to find the best approach how to utilize the available resources. So yeah, you're calculating each cent which you spend. And let me show you the second part of this message.
Start preparing resistance. Find the best and get ready.
Yeah, so the cloud providers are so strong that the resistance appear and the rivals are fighting back their money, and they ask us to prepare the best people to conduct the research how to survive in the cloud world of the future. So here today we will discuss you this topic, and we will try to find the answer, and we will prepare to you so you will be able to join our resistance and work together with us. So be involved as much as possible. Okay, to be serious, this joke about the cloud providers trying to conquer the world is just built on the rumors. People talks a lot that the cloud might be so expensive that you cannot afford it. Some other people says, wait, listen, cloud is not expensive, it's saving your money. Some of them says that the cloud provider gives you unlimited scale, you can use as much resources as possible. Some others says, wait, there is a limitation, limits, quotas, etc. So the everything is not so shiny. Some people may afraid that they will have vendor lock actually, and cloud will not allow them to move out. So you will stick in their technologies and will never be able to switch to the other thing, and that you will lost control on your costs and resources and money, and yeah, you will bankrupt, broke, and everything will be not funny. But we here to discuss about this and where this story actually begin original. So not so far away in the spring this year, I have done two big researches. They had been done locally in the EPAM. So we have community, and we are doing here the technical meetups, researches, and talking about different technologies. And we have talked about the serverless Java. Was my presentation, and after it, there was a discussion with multiple people. We have talked about that the Java is not suitable for the serverless, right? So some people had shared their experiences, like saying, if you start project in the cloud and it's serverless model and you write in Java, you are in bad situation. Actually, you are losing a lot of money. You can choose any different language and it will be better. So some people shared, some person shared the information that they had rewrite everything in Go language and had decreased cost around 10,000 in a month, $10,000 in a month, and such stories. And we had discussed this topic a lot, and I had make a personal research about the serverless cost, and the mission of this talk and research which we are doing is analyze the impact of programming language choice on total serverless application cost and its performance. So we will discuss together two topics. First, we will talk about the cost of serverless, abstracting any programming language, how it built, how it can be increased, decreased, and from which parts it consists. I will share with you some analysis by consultants, by different big companies. And next, we will go back to the performance. We will talk about Java runtime. We will talk about custom runtime. In our situation, this is Graal VM. We have used native images, which are known as an opportunity to make Java much more faster in the cloud. And in the end, I want to make a community call, guys, to you. So let's begin. Some people say that I'm sometimes talking too long stories and like to start from the very, very beginning. But for me, I think it's crucial to understand the general aspects, the main ideas to proceed further. So when we are talking about serverless, actually about creation of new system, we are starting talking from the requirements, correct? We first will communicate with business, and actually business, not we, want to create some system which it needs. And business provide us some functional requirements that they want the system do this and something else. But to imply this system architecture, we need to know some non-functional requirements and quality attributes of the future systems. And before we go further, let's agree with you that we understand the constraints and the quality attributes which are provided to us by the serverless environments. So let's take a look at the constraints. So let's agree that serverless not fit your model if you need some long atomic workloads, which you cannot split in some parallel processes. If you struggle from cold start latencies, so you need very fast, immediate response. You're afraid of vendor locking. I know that right now exists a lot of open source on-premise solutions for serverless, but in the scope of this talk, we will talk only about the cloud providers. And if you, for some security reasons, don't want to move to the cloud, just because it's may be public, you may have some private data, there is some restrictions, regulators. So in this situation, serverless is not for you, and we agree on this. Next, let's discuss about NFRs. So, and quality attributes. Well, actually, what is quality attribute? Actually, any word which end with ability is fit here. So I have copied this list just from Wikipedia, just to show how it works. But let's better understand which quality attributes provided to us by the serverless model. So by serverless model, mainly we are talking about scalability, availability, maintainability, testability, and all other topics. Yeah, so scalability, saying that the serverless can scale in big moments. So you have, I don't know, 1,000 requests, and in few minutes you have millions, and you're scaling that you all time have working environment. If something goes wrong, you will have a new container with a function, and etc. So it's easy to test, it's easy to reuse, and that's actually how the serverless is sold. But which from these quality attributes sells serverless more than other? This affordability. When people talks about serverless, affordability is mentioned more than others because in ideal world, it should make your system inexpensive. So you're just paying for what you use, right? And this is actually the answer on the next question, why serverless sold as affordable. So this is pay-as-you-go model. So the idea that you don't have some server which running all the time, right? And you are paying only for the time when the code is executed. So this is some cost formula. I found it in some consultants research, consulting, very serious guys. But what I want to mention in this formula, when we are talking about cost of serverless, so how to understand it? It's very simple. So this is the cost of all requests, right? How much your code is executed. You should sum all of them. So to calculate the cost of our request, we should calculate the cost of each single request and calculate them. There is 3 important variables. So this is fixed cost per request. This is how cloud providers defend themselves from big amount, very small, cheap requests. So they protect themselves, so they never non-profitable. So to earn money on each request. And next, actually 2 variables which you can change. So you can change duration of request in the serverless environment and cost for a single request, right? So we know that we can scale in and scale out the function. In the example, for example, we will talk mostly about the AWS Lambda as most well known. You can scale amount of memory or increase or decrease, and depend on this, function will work faster or slower and cost more or less. So when we are talking how to optimize this formula, right? So we want our serverless spend as less as possible. So answer is pretty obvious, right? So just reduce the amount of requests, execution time, and cost of single execution. Just decrease everything to a minimum and you will win. So simple enough, right? And I tried, okay, if it's true, let's find the most fast, less memory consuming environment and use it, right? I had done this pretty quick. Actually, I have found research in the medium and came across familiar people. This is Roma from the Orange stream, right? And Alexander, who had created a big topic called AWS Lambda Battle 2021. So they had compared the different environments. So they have made 3 runs. They had created a similar system, which consists from the function and DynamoDB database and gateway, and they have call the function all the time. So there was 3 runs for each function and around 5,000 iterations. Each function have 200 megabytes of memory and compare them between each other. So this is a pyramid with results. So on the top you can see the Go language. It had been, it's a king. On the bottom you had seen Node.js, Java, Ruby, Python, C#, Rust, Graal native images. And so since we know the answer and know how to hack the formula, right? And so we are taking this formula and putting here Go language, right? And so we just win, we are the kings. Sounds reasonable, right? But let's think more about this, right? When we are talking about serverless cost, I think we are looking too precise. I mean, we need to make picture a bit more wider, right? Because the cost of serverless application is not only cost of functions, right? Because when you build the serverless application, it will have a lot of infrastructure around it, right? And this infrastructure not always depend on the programming language, right? So let's right now zoom out the picture and take the whole look on what's going on. So when I came to this research, I had started to think, okay, I know that the Go is fastest, but how much I will spend on the other services? Is there some maybe projects which had shared this information, or companies which had said, okay, we had built a serverless system, it ran in a month and cost such amount of money. On such service, we spend such amount of money, on any other different. And I want to find the percentage and create maybe some average or mean value to understand how much we actually can tune. Because if you will, for example, replace Java with some fastest and more efficient service, right? How much will be actually this change in the percentage? So serverless computing, yeah, as I said, need infrastructure around, and I was trying to find the percentage and find the big AWS cost calculator, which I will share with you, done by Xavier Lefebvre. And what this calculator provide to you? It have different application types. It have different load scenarios, which you can combine. It uses most of standard AWS services. It built for the serverless, and you can compare them. So it had 4 application type. It had collaboration tool like Miro, Lucy Chart, or something similar, a blog, e-commerce, chat, and have different wallet scenarios. So low mean that few users, medium, high, very high user amount is growing. So how the calculator looks like? If you take a look at this spreadsheet, it may look pretty hard from the first on the first look, but I have created such animation to help you understand. So here you can choose the traffic, amount of traffic, and type of this tool. You have different variables which you can modify or use predefined, and this will allow you to see the resulting cost for such abstract type of application. So right now, I propose, for example, take a look at, two most popular one. So we are working in EPAM. We are pretty familiar with e-commerce, right? There is a lot of e-commerce projects in EPAM. So medium e-commerce, what it will mean actually, right? Here will be around 2,000 unique sessions a day, some percent of authenticated users, some amount of assets which they are loading, how much pages they are visiting, and the cost for this small system will be around $70 in a month, right? And please take a look at these calculations and find the lambda in this list. And you can see that whole system cost is around $70, but the lambda is only $3, right? So when we will start adjusting, increasing the performance of lambda and tuning this, we will mostly affect this value, right? So when you are saying that you can decrease cost twice, for example, replacing Java with Go, it's not fully true, right? And let's take a look right now at the big, very high e-commerce. Very high e-commerce. What it mean? Around 1 million users. Yeah, much more assets, etc. And right now, such system costs much more. It costs around 50,000 a month. And let's again take a look at the Lambda. Lambda is taking only around $5,000, right? So this is only a 10% of all costs. As you see here, a lot of money spent on the cloud front, for example, for CDN, for authentication, for working for orchestration of functions. So this is stuff is not completely dependent on the programming language, right? So next, I have take the percentages. I have used this calculator or use all predefined values to find the percentage of lambda for different scenarios, right? Here you can see the table. So I had dismissed the values for with low traffic and take only with medium and higher. And the average will be 15%. So in average, you will spend on the lambdas only 15% of all costs, right? So, okay, great. We had found this value, but yeah, this is around 1/6 of all costs. But I think this is also not everything, all right? Because when we are talking about the serverless application and we are saying that it's affordable, we should understand that actually the infrastructure cost, it's not all the cost of application. Let's zoom out again and think about such thing. Name it TCO. I don't know, have you heard about it, but it's actually trendy abbreviation right now, which states for the total cost of ownership of the application. And total cost of ownership for application is calculated from 3 big topics, big pillars. Is first, this is cost to achieve, cost to run, which we had discussed a lot before in this presentation, right? So we have talked mostly about the infrastructure, and cost to support, right? What is spent after the application had been developed, running in the production, the first release, and next we need to support it. And if we will take a look at very simplified model of this TCO, we will see that this is very simplified model, but we will see that we have talked mostly about the operational branch, and we had completely not talked about the time to market and development, which might lead to unsuccess with much bigger chance than the operational, because in the operational branch everything is simple, right? You know how much you spend on the servers, networking, databases, storages. Cloud providers give you calculators, you enter in there is amount of values, you calculating everything, and fine. But when there came the people factor, right? When you need to find the person who will develop this system, who will support it, it's much more crucial, and the chance that we will unsucceed here is much bigger. I want to show you some statistic. For example, this is a report from the site, from the big recruitment site in the Ukraine, Gini. This is average salaries and availability of candidates with senior level, right, in the Ukraine. So, and we can see that for Java, we have around 600 candidates with our average salary 4,000, and we had much less candidates who will work with Go, so 83 persons, with higher salary. So when you will need to find such candidate, you might spend much more. You can say, oh, we have write everything with Go, it works faster. We we decreased costs in total from 5%, and we had hired a lot of Go developers, and right now overspending on the recruitment and the salaries, etc. So this topic is very complicated and very complicated, and I'm not expert in the recruitment and all this stuff, but I had here such very general things that to hire a developer, the process of hiring development takes around 3 or 6 his month's salaries, right? To find a person, to recruit it, spend it on the technical interviews, on all this stuff. But I provide you the great analysis. I will add it to the comments from the 3 big companies, from the Deloitte Consulting. This is big consulting company BBVA. This is big bank holding from the Spain, which had made the research actually about this topic, and international data company. So they had analyzed the total cost of ownership for this serverless and provide very big analysis for this. So the topic is very sensitive, and you should understand that the programming language impacts not only the operational cost, but also the development costs, and there is very different percentages how much you spend and where. So you cannot just say Java is better or why Go is more or less expensive. So the second part of this research is so actually the research done by us, we want to analyze the performance and cost of the real system. So we have seen some mock testing for the systems, but we want to talk about some real life example, and I want to show you our small architecture on which we are working right now. Actually, I want to add that we are not the super experts. Research actually states for what we are learning something, doing this together, investigating, and asking others to join or share experience with us. And we are sharing our own experience. So we had choose for the serverless the data pipeline, because the data pipeline should use compute much more than other scenarios. For example, than e-commerce or the blog, right? So there should be much more time spent with lambdas. How the system, what actually the system doing? On some of my projects, I had worked with a system which are just transforming the files and distribute them. So in general, the idea was to make something like, with same idea that it's actually used in the world. So this is not just some our system we just used only by us. So it takes a huge JSON array. This is a huge file with size up to 1 gigabyte, and it can take multiple files in a moment, unlimited amount. And next, it should transform these files in the CSV. So the process of transformation from JSON to CSV, pretty standard operation, right? So there is how like one line of JSON. It contains the array. This array have a lot of objects, and we need to create from this object table structure, right? How we will achieve this? There will be 7 functions to do this. So initially, the user put file in the bucket in the AWS, and next function triggered by this and will initialize the processing. So this is some kind of very fast running function which don't do any job and only responsible, for gathering the request and sending a message to the queue. So it should respond very fast. The idea that we wanted from as attribute from this function to respond very fast. Yeah. Next function is orchestrate function. It's, if you guys had seen Saga pattern, it might look familiar to it. Actually, this function is responsible to throwing file from the one function to other in a sequence. So this function used most than others. So it's under heavy load, also should be efficient and responsiveness. So next function is completely different. This is the first initial function. It takes the input file. Input file is always archive. It should unpack this file. This file function don't have a limitation in memory, so it have up to 3 gigabytes of memory in any variation, in Java variation, in Graal variation, to just be able to get the big file in the memory and split this file in chunks. So when this function gets the file in the memory, unpack it and split it in the chunks, all the chunks will be processed parallel by validate function. So with validate function, we want to emulate some kind of CPU intensive task that you need to take a JSON in the memory, right? Run according to the schema, validate everything, and next transform the valid file in the CSV. After that, everything also is done in the parallel, so there is a lot of messages. We should combine these chunks in one big file again, and also we want to do this in parallel. So there will be a lot of messages, and we will upload this file partially using the feature of S3 bucket like multi-part upload. So we are uploading the parts of the file from the different function instances and next combining them together and again putting back to the archive. So this is sample system. So it should emulate as function which should respond fast and function which doing some work. And what had we received in a result? So actually how we have tested. So for testing of lambdas, there is a tool which you can find in the AWS documentation. This is open source tool to test the lambda performance. You can actually see here the 2 variables which we have discussed initially. So invocation time in milliseconds and cost in the dollars. So what have we know? And that if function doing a lot of CPU work just scale up, that was our initial things. And if it's doing some, have a lot of idle time, so we will just scale it out in the memory, and seems this should be the most efficient cost. But is it work? And is it work always? And the answer is actually, as always in the programming, it depends. So with this calculator, we have run function multiple times. This function, this feature, power tuning tool, this is a set of step functions. You just deploy them in the AWS with one click. And next, you can choose your function, provide the ARN for this function, and execute this state machine. It will try to run this function with all our available memory setups. And next, we'll build you a chart. I will show you these charts. And you can analyze which setup is better for you. So here we have compared the register file job function, and you can see here that, for example, Java function and Graal function have completely different amount of memory, and you may ask me why, and I will answer you that this is the most cheapest setup for each of functions. So you can see here that the most cheapest setup for Graal VM first work faster, consume less memory, and cost less. So if you will take a look at the chart, so this is how the chart look like, which the power tuning tool generate for you. You can find here that this is under the arrow the longest invocation time. So you can see that with minimal setup with 200 megabytes, we will run more than 100 milliseconds. Next, on the other side, in the most below, you can find the most fastest running setup for this function, right? So if you have 3 gigabyte for the function, it will run more the faster. But the most cheapest, actually first, the most expensive variation will be here. So you see this spike. This means that you will pay for each of execution of 2800 function, like some amount of zeros and 9, right? And the most cheapest is actually will be this. So this is the most cheapest variation of this function. Each memory execution you can configure in this power tuning how much test run. So I have set around, as I remember, of 50 or 50 executions to find this value. So actually value can differ a bit between runs, so better to do them multiple times. Yeah, and in from other side, we can see the function from Graal. You actually can see the difference here. First, because the function using the Graal native is not benefit in the invocation time. As you can see, with any different memory setup, the speed will be mostly the same. So this difference which you can see is just because this function all what is doing is few network calls. So I think this is because the latency is might different between the executions, but this function is not benefit from the increasing of memory at all. So the most cheapest setup is for 200 megabytes, right? So it will be from one side, maybe a bit longer than others, but not so much. But it's actually much more cheaper. And yeah, this is very simple function. Let's take a look on the orchestration function. It's absolutely the same as the previous in terms of work done. So this is only API calls for this function. So it's just calling the database and pasting messages in the queue. And same situation again. Graal outperform this function. And yeah, so the graph is pretty similar here. So the less memory we have, the more long is invocation time, more we spend, we getting faster. But you can see here that on the sum step, you will stop get the benefits from the increasing of the memory. So here somewhere, yeah, you can find that the cheapest execution is actually 500 megabytes. But if you want to fine tune it for speed, you can see that invocation time start to decrease somewhere in this step, and the line is mostly straight. So you are spending much more, but you don't get benefit in the speed, right? So for example, for this function, scaling to the minimum is not so optimal because it will run much more longer, will be expensive, more expensive than the other. Yeah, and the situation for Graal is pretty the same again. Graal don't get the beneficial from the increasing of the memory, so increasing of CPU speed. So the fastest, the cheapest will be the most smaller function. So you can scale up it to the 3 gigabytes, but it will not benefit in terms of performance. But next, the situation is changing. As you can see here, the most optimal setup for validate file path function was completely different. So here we can see that the memory consumed by the validate file path function for Graal had been much bigger and much more expensive than the Java function. You may ask me why this happened. Let me show you the chart. So you can see that for Java function, with increasing the memory amount, the invocation time also decreasing, right? And at some step, we can see that the cheapest is 500 megabytes as always, and always fine. But right now, for Graal, we don't see the picture as before. So we don't see the straight line, mostly the straight line, and that we don't get the benefits from the increasing of memory. So right now we start to getting this benefit. I will explain right now why. So you can see here that with same invocation cost, right? So you can see here this straight line of invocation cost. We will receive much lesser invocation time, right? So you will pay same as for 500 megabyte function, which will execute for 6 seconds, and you will pay mostly the same amount of money for half 1 gigabyte and a half function. So there will be same amount of money, but it will execute just 4 times faster. So again, this lead us to situation that we need to fine-tune actually each function separately. There will be similar situation for transform file part function, mostly similar. The Java have lesser costs and work faster. We will talk about this, why this happened. And you again can see that the same situation, that for Graal we have Pareto, when the invocation cost is same, but the invocation time is different. And pretty same situation for merge file part function. So I will skip a chart because they're pretty similar. So after we have found the most optimal configuration, we have tried to run this on some real system, and on our with some real data. So for example, we will take one and process one file with size of 500 megabytes, and this will lead us to such setup. So register file job function will be executed one time, orchestrate file job function will be executed 100 and half, and you can see different amount of executions of each other function. So you can see that validate, transform, and merge will all be executed 50 times. This is because we split 50 megabyte files in 51 chunks, right? So each chunk is 10 megabyte size to process them in parallel. And next we NVN combine them and pack in the archive. And the situation here is pretty interesting. First, you can see here that the unpack and pack archive function had loss in performance to Java. Even this was just one execution. So this had confused me a lot why this happens. But you can see that in any other situation, so this is the average duration for all function. The Graal outperforms. So right, it's run much more faster. If we will take a look at the code starts, there is again Graal outperforms, but we see issues here with unpack and pack archive functions again. And this is the minimum duration. So this is warmed up instances, right? So you can see that the difference again pretty big here, but it's decreased a bit. So we can see that Java started to perform a bit better. If we will take a look at this same system, which run under bigger load, and we'll compare which system is perform better right now. So right now we can see different amount of execution. So we had multiply everything by 10. So there will be much more execution of orchestration, validate, and all other functions. So they will be able first warm up and scale. And let's compare this with stable spreadsheets. So for average duration, we can see first that Java wins in the merge file part function, right? So under bigger load, seems Java function had warmed up and outperformed Graal function. Also, you can check that the percentages in difference for validate and transformate function also decreased. In the previous run, it was around 80%. Right now, it decreased for 50-40%. You can see here that the register file job for Java is still running much slower. This is because the S3 bucket trigger is triggering multiple instances and all of them starting in the cold start, in difference with other functions which are triggered by SQS and they're not scaling so fast and have less amount of cold starts. So there is one instance which all time consume messages, and only after some time there is additional instance. But when you are triggered by S3 bucket, as I understand, they trigger multiple instances in one time. So when we have put to the bucket 10 files immediately, there was more cold starts for in general. And you can see here that for max duration, so for cold starts, yeah, Graal is better. But right now for min duration, you can see that the situation changed. For warmed system, so it's run 10 files, we can see that Java start outperform under Graal, right? So we can see that transformation and merge start running much faster in the Java. We can see that validation is pretty close to the Graal. We can see that orchestration also is pretty close, so there is only 10% difference, actually 3 millisecond difference. So seems under the biggest scale, Java start performing better. So the execution of one file for Java, so we have throw 10 files, and for Java, they had been processed for 260 seconds. For Graal, it had been processed for 180 seconds. So it seems Graal faster, right, in total. But is it expensive or cheaper? How, guys, you think? I will be actually interested to see this answer in the comments, and I will take a water. Which of system had been cheaper or more expensive? So actually, total execution of these functions for 100,000 files, if we will extrapolate previous costs, I understand that this is very approximate calculations, but the Graal VM will be more expensive right now. And this is, we have been confused with this a lot, because you may ask us how the code is differs. Actually, it's absolutely equal. So the code is the same. The Java functions are written in the plain Java. Graal functions are written with Micronaut, but the Micronaut is, we have used the hexagonal architecture. So the all code is under abstractions. So the difference only in the handler, right? So the code absolutely be simple, and we start investigation. Actually, why the Graal more expensive for us? What is the reason? What's going on? Because we had been thinking about completely different. This is the X-ray logs, for example, for pack archive function, and you can see here the 2 points. So first is get objects. This is when the pack function downloading the file, and next is the put objects. It's when it uploads the packed file back to the S3 bucket. And the space between these 2 points is actually the transformation of the file, actually the packing. That's how we think. And we start investigate this point, and only code which was between getting file from the bucket and uploading it to the bucket, this is this function. So all what was the difference, how we think, is packing file in zip archive. So as you see, nothing here which should work slower in the Graal. We have read a lot about which issues can be here. We had found that Graal have issues, for example, with array copy. Maybe this may impact, but it had been fixed in previous versions ago. So very hard to find information. But next we have done additional round of testing and found that actually the problem not in the file transformation. So packing is pretty similar, but we facing really strange issue with file downloading. For some reason, so this code is the same in the Graal function, same in the Java function. Downloading in the Graal function much longer. So it twice longer than in Java function. And we are still investigating this issue, and this is no clear reason for this. Maybe this is the issue with AWS SDK, because seems it's just working slower. So we had consulted with some people, and seems it's just works like now. But what I want, the answer is slow downwards. But what I want to mention here, that let's get back to TCO. Let's imagine that we some guys which should develop the system to the customer, to the business right now, and we are trying to set up this Graal. So we are investigating, we have facing the issue, and we don't understand why, for example, downloading Graal running much longer with than in the Java function. And we're spending some time for this, right? And imagine that we are spending days which are paid for the customer to just find this issue. So maybe you will benefit much more if you will write everything in the most common and most shared language, and it will get you more profit than investigating and beta testing some other stuff. I'm still interested why that's happening. So we have been advised by some guys, by the people who work with Graal, to try different properties during the compilation of native image, for example. And this is pretty exciting to work with native images, because you recommended some properties and you're trying to Google them, and Google showing you blank page without without any results, because it don't know anything. And okay, next there was some typo in the property. I had removed it, and I had found some documents in the internet, but it's so not described, and you have no understanding what's going on, and you should figure everything by yourself with comparison with some other language where is everything works fine, right? So you will need to hire more experienced developers, right? Because we are getting back to SEO. You will need to, for example, to developing this system in the Java or Graal, you will need to hire more senior developers. Maybe they should be more experienced than me, to find the answer to this solution, if it have the answer why it's happening, right? So is it really what you want in the production? So the research is ongoing, and what I want to make in the end, right now we are trying to rewrite this system in the different languages. So right now we have finished implementation in Java, in Micronaut, with native images. Right now it's going work to write this with Spring Native. Also, one person joined us to rewrite this with Quarkus. Guys joined to write this in the Python, Node.js, and we are planning to write this in the most languages to just make a funny, interesting research and compare everything with everything, and just create these spreadsheets and compare everything. So for us, it's pretty interesting. And if you are interested and you're from EPAM, you can contact me in the Teams. I will guide you how to join. We have big documentation, how the system works, how to deploy it, how to configure it. And yeah, so you can participate here. If you're not from EPAM, I think we will open source the code. I mean, right now it's hosted in the EPAM Git, but I think we will put our findings in the GitHub so everyone can join and contribute. And yeah, we want to create a comparison, because as right now we understand that we cannot pick up one scenario and say that Go outperforms. We need full kind of comparison. So we need comparison of different scenarios and etc. And I think this the end. I have shared all the information which we have on the current stage, on the current step. Actually, this was the initial step of our research. We just have developed prototypes in Java and native images and compared them. And right now attracting others to join us and contribute to this research. Or actually, if you are some Java champion, not from VPAM, from anywhere, or you have worked in Graal or somewhere in Oracle, and you can explain us why the downloads take more in the Graal than in the Java, actually the same code. We will appreciate this a lot. Yeah, so this is everything from my side. I will be glad to hand over to Tatiana or Igor.
So actually, we have a lot of discussions below our speech. So basically, let me try to find the most interesting ones, because we have kind of small amount of time to proceed. So the question, did you try lambda snapstart in your research? So have you considered it?
Sorry, what lambda snap?
Snapstart. This is kind of a new tool set for improving startup performance in AWS.
No, I have actually not heard about it yet. Yeah, not here, but I think I will take a look on this, because I think no one had mentioned it during the research.
It's interesting. I guess we will proceed discussion in Discord after a couple of minutes maybe. And AWS is a group on Tenegro. If you are with us, you can join and tell more about this. I believe not only Mykyta and me did not heard about Snapstart. Join us in Discord.
So actually, I've shared links to our continuation of the Discord discussion, where I could try to sound all of your questions. So as I understand, we should give a stage to another speaker. Am I correct?
We still have maybe 10 minutes, and we can answer a couple of questions more here.
Yeah,
Okay.
fine for me.
So let's move on with the questions then. And one of the question was, so basically there was kind of discussion in chat, which led to the following question. What about the heterogeneity or homogeneousness of an application? Is it better to use less different languages and don't care about lambda's cost? From your research results.
Yeah, I can answer only in general way, because so if you're talking about hiring persons which will work with different languages, you should understand that someone and they will develop this system in the different languages. You understand that in this TCO someone should support it, and you will all the time need to find the persons who know all the languages which you had write. This is good to write, when the microservices begin. So some companies allow to write everything in language which you want, and people was just sitting and thinking, okay, which letter for programming language we had not used yet, and okay, A, let's choose something for A, and it's a mess. I think we should make profit for business, not tech for fun. I mean, we can make tech for fun in our projects, for example, in such research, and you can join us and we have fun here. But I think when we are talking about someone's money, I think better to, we'll have expertise with one technology, because, for example, if you have expertise in Java, right, you have not so good expertise in something else. So this is my overview, but it may differ if you have other experience.
Yep, actually, the worst case of choice of language which I saw sounded like it was a great opportunity to study a new language in production project. That's amazing. Yep, so I also totally agree that the choice of language should be a rather important point in general, while and all of the points which you've sounded during the presentation should be definitely considered. Yep, and basically a lot of feedback regarding the animation of your presentation. I think that it's worth to to mention this, that guys say that this is a great presentation, especially great animations. So actually I think that the other questions mainly are about the comparison which you've shown, and for some guys, just an interesting point, some guys, a lot of guys basically also were very impressed by the fact that GraalVM showed such interesting results and unexpectedly worse results in comparison with traditional Java. So actually I think the last question will be from my side, and all other interesting points which guys sounded we will try to discuss in Discord. So basically what are so you've already sounded some of the further plans of your project, of your initiative, but do you consider any further enhancement in terms of other serverless services, like for example AWS Fargate or something like that. Are there any area of enhancement in other AWS services for your investigation?
Yeah, so this research is done by people which are just joining and want to contribute, and we are pretty open. We are sharing our experience, and someone, we just not came in and saying that, hey, listen, you should write this in Quarkus to the end of month. No, completely anyone can came, and we just showing the system which exists, and you can compare it with anything what you want. Actually, we had not planned to compare with Fargate. Fargate is actually containerized solution, actually working with it in production. I know that you can run actually the container in the Lambda environment, not in the Fargate, but we had not tried this. Maybe it will be also interesting. So as I know, we had discussed with some new person which joined to us that it will be interesting to try this in the open source. I forgot. Knative technology to run serverless on premise and compare its performance, for example, with some existing solutions. How to deploy the cluster.
Thank you. So, guys, please feel free to join this interesting project and to contribute to it. Hopefully, this will help us to have the comprehensive view of how basically the overall serverless systems in AWS might work better and more optimized way in terms of cost as well.
Totally agree with you, and it's moreover, it's changing mindset. More of developers, not more, but in the very beginning, middles, seniors starting talking about performance in terms of only Lambda, speed of running something, execution time, and so on. And here we thinking very, very on high level. We're taking a look not only on performance, but on the developers, on market, and all the things. So it's rather adult mindset, and this project help not only became more experienced in languages or lambdas, but more adult, let's say. Okay, and we did not highlighted that most of our viewers answered in correct way. So Java is cheaper. Mykyta asked, and we see that, for example, who was first? Hunar Letsko. Great. Very attentive and very fast answer. Thank you. And all others, of course, Ilya and Vladimir, all who answered in time.